Good morning. So, the second part of civil engineering practice is that of structures and buildings. Buildings and structures are the backbone of civil engineering. Starting from a hut, a mud house, the shelter of a common man, to a multi-storied building ranging to sky high, skyscrapers, the wonders of the world start going on listing the civil engineering marvels. The recent Burj Tower, buildings and structures on comfortable land, buildings and structures on difficult land. The structures and buildings there to resist the earthquake forces, the heavy winds, storm, and any unanticipated eventualities. It's really a challenge of a civil engineer. The structures may tell the history, they may stand for centuries, but they stand in an environment where you have to expect the unexpected. So, building technology plays a very important role in bringing out structures of par excellence, structures having visual effectiveness, visual impact. Buildings of inexplicable elegance, image, accommodating thousands of people. These people reside, these people takes their occupation, sit comfortably, believing a civil engineer that the roof above them will stand, take care of the external loads. The bridge which they design, whether it's a road bridge or a railway bridge, people fly on them, drive on them, believing a civil engineer, a structural engineer, a construction engineer. A cinema theater, a huge cinema theater. You comfortably go, enjoy the movie. When you look at the top, you see a ceiling spanning several meters, but you are not frightened because a civil engineer would have designed it in such a way that it is safe for all external loads. Multi-story buildings, stacking vertically. People live comfortably. believing a civil engineer. So the building technology or building construction has two parts, the material part and the construction part. Building technology deals with building materials, building construction, building planning, building analysis, building design, and building detailing. So building technology is the process of understanding and employing various materials for construction. The materials may be from natural origin or of semi-natural in nature or totally artificial, man-made or synthetic. That is one major part, building materials. That we will discuss first. Then the building construction, the process of using these materials in a very scientific and cost-effective manner, optimizing the materials, using them in the proper amount, in the proper shape, in the proper form, the proper location. That part is the construction part. So materials and construction are two streams of building technology. Then the planning of buildings. Each country will have a planning code, functional planning code. In India, you have a functional design of buildings for industry and other than industries, SP 41. There are different Bureau of Indian Standard codes for materials and constructions, specifications, and for methods of tests. And you have one major codal book revised very often, National Building Code. National Building Code gives so many details regarding building practices, materials, building services. Building technology's next horizon of activity is the planning of buildings according to the type of buildings. Each country, each nation will classify buildings. National Building Code classifies buildings as type A and subcategories of A to type H. A pertains to residential buildings of different types, educational buildings, entertainment buildings, hospital buildings, office buildings, commercial buildings, specialized buildings, hazardous buildings, like that the list goes. The planning requirements will be according to the type of the building, type A to type H. Then analyzing various components of the building. Structural analysis is another part, functional analysis is another part. Building technologies usually deal with the functional analysis. A structural engineer deals with the structural analysis. Once the building technology makes a form, then the assembly of those forms will be structurally analyzed by a structural engineer. So it is an iteration procedure, it's a repetitive procedure. The building planning deals with analysis, synthesis, evaluation, then the design. It's an elliptical form. You have the analysis of the various components, then synthesizing the various components, then evaluating their performance, then the design. You again do this process till you get an optimum design satisfying the structural, functional, aesthetical requirement as we have seen yesterday, and also to the satisfaction of the end user. User may be an individual or a firm or a company, according to the type of the building. So type of the building is the deciding factor. The user specification is the deciding factor. The coded provisions are the deciding factor. Then the available materials, their configuration in such a way that the structure will be strong, durable, healthy, and time tested. That is the analysis. Analysis is the process of differentiation. You put everything separately, dissembling. Then take part by part. Then start connecting them. Synthesis is the process of integration. After analysis, you just start putting them together. Just like playing cards. First you get the cards, you analyze them, then try to join them according to your availability. You synthesize. So components will be connected together. So that is the synthesis. Then you evaluate. Evaluate is the process of the outcome. How, by combining these components in this way, are you getting the comfort? Will the structural configuration will be over? Oh, okay. Will it give you the required functional efficiency? And will the elevation, the front view of the building will be visually appealing? Once it is okay, you design. Functional planning of buildings. Building planning, designing and detailing. So it's a system design, analysis, synthesis, evaluation, and design. This process, this scientific process evolves a structure or a building, and that process is called systems design in buildings. So building technology takes all components as separate entities, analyze them separately, evaluating their capabilities. After evaluating their capabilities, putting them together, fabricating them together in paper, not actual fabrication, on paper. Then evaluating their performance, discussing with the team of stakeholders. Once it is okay, you start designing. So any building operation, whether it's a small project or a very big project, process of analysis, synthesis, evaluation, and design will be taking place. Only the number of iterations, the number of trials, the number of interactions, number of sittings will be more whenever the structure is highly involved, having a lot of components, a lot of complications, difficult structures. When the structures are difficult, this process of analysis, synthesis, evaluation, and design will be done different levels, different phases for a long time. Then only the actual construction or execution of the project will take place. So building technology is a stream of civil engineering, which implements, which practices, which executes the work of construction, planning, this analysis, design, and detailing of any type of building and structures. Any type of building and structures. Bridge is a structure. A tower is a structure. A frame is a structure. But if they enclose a space, when a structure or a structural component encloses a space, then it is called a building. So any structural arrangement encloses a space and divides the space into two parts as a micro space and a macro space, or a controlling space and a controlled space. Then it is called a building. Thank you. God bless.